Now we can see.
So today's session basically related to integration characteristics. Basically, this is part of, you can say, Salesforce integration pattern, which is around 17% of our certification exam. Okay. So agenda. This session is for whom? Who wants to go with this session? So the person who wants to join from different technology and they want to join as an architect in Salesforce, like who already working in .NET, who are already working in Java, and they're switching to the Salesforce. So they should be aware of those integration characteristics, okay? Or the person who is already working as a developer in the Salesforce or is a tech, and they want to go with the basically in architect's kind of role. So before being an architect, what are the things he should consider, he should know? Okay, those things we will basically learn, or we can see in this session. So before starting with those architecture pattern, let me see what are system integration basically. So in first video, actually we have explored a lot of options about the integration architecture. So we have also learned that this integration is the process where multiple subsystems are actually connected in a single larger system. And that larger system or that unit basically have all the information from all connecting system. You can see all those things as a dashboard. You can see things as a connected system. So it is very much required. Like just take example in your organization also, in like we have HR system where who gives all gets records of all you can say employees. There's a financial management system which takes care of our salary and other package. So there are different system connected with each other. Okay, so there is a need of system integration. Guys, 1 second. A lot of people actually joining in middle. Okay, they already joined. Okay. So when we want to go with any kind of integration, basically, so what are the things as an architect I should consider? How I should connect with the different system? So normally we have three kind of architecture. So basically, whatever the points we are going to see in this session, basically all theoretical but very important. Okay, so we have a three kind of architecture. One is point to point, second is hub and spoke, and third is enterprise service bus. So all has very good, like they have advantage and all have some kind of a disadvantage as well. So we will see all those advantages, all those disadvantages also, and then we'll see what are basically in which scenario these three will be applicable. Okay. So first architecture pattern we have in integration is point to point. So point to point, you already know that one point or point basically a system. One system is connected to the other system in direct way. There is no middleware, there is no middle point who actually orchestrate or they are monitoring. They're directly connected. So when we are using in Salesforce, when we are connecting any writing any code for using Apex callout, so we are directly connecting with the system. There is no middleware in between. So there actually the need of or that then we go with a point-to-point interaction. So just take example, your client is a hospital, and using a hospital, there are a lot of doctors are there, and you want to, whenever the new doctor's appointment is required, you want to validate their credentials. So their credential is they have a degree, MBS degree, or they have other degree as well. So you want to validate all those degree, you have to call a third party system. So there are need of one to point interaction. You will directly call the third party system, they will validate the data and they will give a proper response to you. So there you will go with a point to point interaction. Okay, so what is the benefit basically? You can see in this diagram also that each system like a CRM, inventory, SCM, sales, data warehouse, financial, HR, and different other system will be there, and each system is connected with other system. they there is no central hub, there's no middleware, they are directly connected with each there. So that's why it's called point to point, two systems are connected directly. So what is the advantage here? Because you are directly connected, so you know what are the requirement for the interaction, so it's very fast to develop. Okay, because you're now developer already knowing Apex, they can easily basically directly connect to the other system. They're easy to implement. You could, because as developer they're already working in a Salesforce environment, they already know those coding, so it's very easy to connect with a third party system. Now what are disadvantage of point to point connection? The first thing, because one system is directly connected to the other system, so they are tightly coupled. Tightly coupled, they are basically they are directly connected. So one of the server, one of the point is down, the interaction will not be done. The transaction will not be happen. So that's why there is a problem that in this case, if server is down, or then the client cannot basically get the proper result. They will not get the proper output. So that this is a problem with the point-to-point interaction. And the second point is difficult to scale. Let's take example I have given for the hospital and the medical practitioner. Okay, so that practitioner API which validate the system. Let's today they are getting 100 requests, and as we at the medical system or medical grows, that these systems grows, that there are a lot of requests for the verifying the system or verifying medical practitioner will grow. So in that case, your system should also grow. So actually that growing, you have to grow your API capability, your system capability as well. That's basically called scaling. So scaling basically come two terms. One is horizontal scaling, and the second is a vertical scaling. So in horizontal scaling, what you are doing, you are adding multiple system to your system, existing system, so that the request or that system is get the powerful system, and they will give you a proper output in the timely fashion. Okay, and in the vertical system, what you are doing, you are enhancing, you are increasing the power, CPU powers, like you are increasing the RAM. Okay, so that the request process immediately. So in point to point, that is very difficult to scale your API servers. The second use case we have hub and spoke. So hub is basically the central system. You can diagram also. There is central hub basically, which gives you request, basically which handle all your requests. Other system which is connected to that central hub, that are called spoke. So that's why the spoke and hub model. So all connected system is connected using or monitored through the central hub. And where this kind of scenario you will come, just take same example of hospital. Okay, because hospitals, they have to basically apply a lot of government norms, and in government norms there are different kind of institutions which gives a lot of norms to, and it should be basically applied on the hospital, otherwise maybe their license will be cancelled. Okay, so now question, how the hospital will know that okay, the new regulations has been published by the government? They are not aware of that, because if you go with the point to point interaction, if you call the government site, but you are not aware that new notification, when the new notification will come. So there are need of a central hub which gives you all those notification related information to the caller or the client, in this case our hospital. So in this term, as a Salesforce, where that applicable, how you Salesforce implement hub and spoke model. So if you have heard about ISV partners, okay, so they actually develop a system. They get all the information, all the notification from all the your government agencies, government institutions. Once they collect those information, all those notification, new notification comes. Once they collect those information, they actually forward that notification to the caller or the hospital, basically. So in that case, the hospital is not directly connected with the government agency, and they are not actually pinging every time. They are just connected with the central hub. Central hub is getting information from the institution, government institution, or government agencies. So central hub is pushing all those notification to the hospitals. So in that case, we are not directly pinging. So this is a benefit where we are not directly connected, but we are getting all the benefits, and we are overcoming the disadvantage of point-to-point connection. Okay, so you can see that each system is connected to the hub. Okay, and data transfer, all the data transfer is done through the central hub, because there is no connection, directly connection between spoke and the government agencies. Okay, or the third party system. They are connected to the central hub. So now, what is the advantage of this hub and spoke model? So this model actually works very well when we have less number of spoke. But as soon as the spoke will increase, the count of clients will increase. Might be there a problem with the response. There's a response. Okay, and if the central hub is doing a lot of operation, might be that also kills the problem. Okay, that the performance could issues come there also. So in that case, what is the disadvantage? We know that, okay, central hub will give you response on the time. Okay, the disadvantage of this kind of model is there's single point. Central hub is a single point for all the operations. So if central hub is down, all connected system is down. They will not be able to do anything. This is the biggest problem actually, the central hub concept. And if as soon as the transaction is getting increased, of course, I told you, if number of connected system increase, it might create a problem with the performance. And it's very hard to scale, because might be, yes, we can create a central hub, multiple central hub, and we can process all those things, but it's actually very difficult to scale central hub as well. Okay, the third system with the is enterprise service bus. So before going with the concept, I want to go with the same model or same hospital concept. So where a doctor writes the prescription, and that prescription goes to a different systems. Like we have pharmacy app, we have a billing app, we have a dietary app. Okay, we have a laboratory application or the pathology lab. So based on the prescription, all these department has to work. So basically, that's the person is getting hospitalized. So the dietary application should know what are the diets I have to provide to that patient. Pharmacy app should know what kind of medication has been prescribed, and I should basically provide to that nurse or taking care person that, okay, you have to provide this medicine to that particular time. Billing app should also know, okay, how much money or we are getting spent for that patient, and same the laboratory if there any kind of testing is required. So the problem is that these all four systems are written in a different language. If they are written in a different language, they get a different kind of input process as well. Like you can see the example, laboratory application only support text format. The pharmacy app support only CSV. A billing app only XML, and the dietary application can support JSON, because they are written by different language, and they are basically developed using a different partners. Okay, and maybe these applications could be a legacy system as well. Okay, so the legacy system, of course, they are written in different concept. So now question, if this kind of a scenario is there is one is the you can prescription writing software, and there is four other system. So how to connect this kind of uh, process, okay, so that whenever the prescription is returned, it will go to the each department, each application, and they can process those applications without any problem. And there is a need of enterprise service bus. In this case, point to point and hub to spoke will not work. Only the concept will come is enterprises service bus. So what we have to go in this case, whenever the prescriber or sorry, the doctor will write a prescription, our enterprise service bus will create a message queue. Basically, we call it message queue. That message queue will go like a bus kind of services. Okay, bus like our architecture, it will go and wherever this application is basically subscribed, like this subscription, basically the prescription writers application is subscribed by these four applications. So that message queue will transform based on their requirements. So if the laboratory application needs text format, that message queue is transformed in text format, and that will be used by laboratory system. In case of pharmacy app, the message will be transformed in a CSV format, and that will be used by pharmacy application, similar to that billing application and dietary application. So basically, ESP into service bus is standards integration platform, or we can say the middleware like we have MuleSoft right now. Okay, so that combines different kind of platform in one big platform, which can support you messaging, different kind of messaging. As I told example, the one kind of message is transformed based on the required application, that is transformed easily with a different format. It can transform, it can do the intelligent routing, and there's a very secure as well. In MuleSoft, if you want to, when you are transforming data, if you want to that particular record should not go or should not be visible to other person, you can hash that particular record as well. Those kind of mechanisms are already available in enterprise service bus. So what is the advantage of that kind of mechanism? It's because you know that you are integrating multiple systems which is are not of same kind. Those system are could be a legacy system, those are could be a .NET application, but all those systems are connected using message. That is a very important point, that they are connected to the message, and that at required time those messages are converted based on the application requirement. Okay, so this is an advantage actually. Disadvantage because it do lot of operations on your requirement in your message, so sometimes it can produce a performance hit also, because you have given as a JSON request. After the JSON, they are converting into different format. So if it's the system or the middleware is converting two times or many times, it might have created a performance issue. So if you see in Salesforce we have platform event. That platform event is basically, you can say, is working at the same concept as an enterprise service bus. So whenever you are raising an event in the platform event, the subscriber is getting information and they are doing operation after that. Okay, so platform event is a implementation for enterprise service bus in our system in Salesforce. So now you got, let's say you got the requirement, okay, that we have to connect the third party system. Now question, should we go with inbound integration or we should go with the outbound integration? That is another area where architect has to think about that. Okay, so inbound integration is where Salesforce expose their services as a Salesforce architect or Salesforce org is exposing the service, and third party system is connecting or they are calling that service. Okay, and they are calling service and they are updating all data in our system. Their inbound integration is there. The second is outbound integration, where we are consuming third-party system using Apex callout and external layout. In both cases, the security is implemented very thoroughly. In case of inbound integration, we normally go with the connected app application where all the permissions is set up in profiles. Okay, and we are providing that particular user to the third-party system. In outbound integration also, when we are consuming their system, we are going with different kind of security which the provider is giving us. We are going with all those kind of authentication system. So you should consider, let's as an example, I want to validate the pharmacy or the doctor using third-party system. So you know that we need to call external system. So that will be your outbound integration. The second concept will be there after the second, probably in the next slide we will go with inbound integration as well. The next concept will be there, like what kind of response you will get when you do the third party integration. First is request and response pattern. Okay, so you can see the request is going on to the third Salesforce. So client prepare and send request to the server. Server process request and return response to the client again. And then what the client uses the response and show as a required format. So this kind of format we call as a request and response pattern. So normally if you are creating an API, okay, and other third party system they're calling, so they will go with this approach only. They are requesting our services and we are giving a response, and they are showing that as a their desired format. Second kind of pattern is callback pattern, and why that when the callback pattern will be used. So take example, you in a Salesforce we have account object. In account object there are two fields, you can say mailing address and billing address. And if you want to search data based on that address, and let's take example, you have 10 lakhs of record in your account object. So when you are going to search records based on address, the system will take a lot of time. Reason, those address fields are not indexed in Salesforce. So might be it will take 2, 3, 4, 5 minutes based on your volume of data in your org. Okay, so what you will do when the third party is calling your API, they will not going to wait for 2, 3 minutes. So what is the pattern you will going to use? In this case, this kind of pattern, the callback pattern will be implemented. So what you will do, client will prepare and send request to the server. Server process the request and return a response to the client that, okay, I have acknowledged your request. Okay, I have, sorry guys. So Salesforce prepare request and send to the server. Salesforce is giving the request, or the third party system also taking the request. Server receives and acknowledges the request. This is acknowledging that, okay, I got your response, but I am not sending a response back immediately. I have taken your request. Now I need to process that request, and based on that, I will return you back. So the after that, server will process the request and send response back to the Salesforce system. It might take a line 2, 3 minutes, might be take a 10 minutes, probably in a half an hour also. It based on the kind of mechanism, based on requirement we have implemented. Based on that, it will process the request, and then after that, when we receive the request, the client will go and display based on their desired required output. Okay, so there is a need of a callback pattern where immediate response is not required. Then we will go with the callback pattern. The other consideration is required as architect is what is the response or what is the process time is required. How should consider, I should go with the synchronous, I should go with the outbound asynchronous process, or I should go with the batch process. So in synchronous process, basically, you know that whenever the interaction will be done with a third party system, they will get the result immediately. That is a synchronous process. It's almost very near real time scenario is there. Okay, just take an example. I have given example. You want to validate the prescriber, so it's a real time. You will send a request, you will get a response that, okay, this particular doctor is licensed or not. The second is asynchronous process. Okay, by mistake it's written as outbound integration process. So it's asynchronous process basically, where actually you are sending a request and you are processing the next step. You are not waiting for the response, okay? Because that particular job will take time, and you should not wait till that time. So you will forget whatever you request you have given. And when the response will come, at that time you can do the operation on based on that. Okay. The third type of process is the batch process, where a large data volume request actually need to be processed. Okay. So in that case, because we know that Salesforce has a limit to process record, we around 200 in a one API call, and when you are using Apex callout, then the limit is also decreased to 100 only. So what you have to do, if you have large data volume, then you have to divide all those process requests, or you have to divide as a chunk on less than 100 records, and you have to process those records in queue manner, divided in chunks basically. So there the need of batch processing. So you as an architect, you should consider which kind of process you should follow. The other process, other factors we have transaction management. So transaction management is very important. Why? Let's take example. You are creating an API, and in using that API, you are inserting record in 5 or 6 Salesforce objects. Let's take example. After 2 record inserted, in third record insertion, there a problem, and it could not insert. So in that case, you should not insert record in 2 object as well. The automatic there is a concept of ACID. Okay, the say all those record, all the transaction either should be successfully or it should be rollback. So it should not be done as a partial. Okay, so there are you need to go with the transaction management. You should consider transaction management is a very much important factor while integration. The second is orchestration. So basically, when the third party, this kind of a system or a monitoring system, basically which monitors, okay, so what if any kind of request fail? What should I do? Okay, what should I do when a more secure system is required? Then there's a need of ETL tool like a MuleServe, which take care of all those factors. They transform, they orchestrate, like they can add a new proxy in your system so that your request will be more secure. They can add a firewall in your in process request, so they can handle all those things. Salesforce limit is very much important because if you are if you are calling a third party system or any other third party system is calling your system, so basically the limit is very important. So you should always consider limit as one of the factor to decide while the integration. The fourth form is large data volume, because whenever we do the data basically large data calculation or large data upload using any of the framework, maybe the SOAP API or the REST API bulk operation you are doing, or using an ETL tool also, because they are inserting a record in our system itself. And if we have some workflow rule, we have a trigger, we have actions written on those objects, they might create a problem while the bulk data is being inserted. So these are the important factors basically, which is you should consider as an architect while designing a new integration project. So I think I'm done with the this integration for characteristic factors. If you have question, you can ask. Because we have time, then I will go with the other session basically related to the best practices about the DML operations in the Salesforce SOAP and REST API.
Danik, if there is a scenario like where we are integrating with third-party system and we have to upload files of size more than 6 MB, if it is synchronous or asynchronous 12 MB, so how
Mhm.
should we handle such kind of files while integrating with a?
So this is already actually being implemented in Salesforce, also in other third-party vendors as well. If you see we have the concept multi-part form data. Okay, so in that case, what actually being done there, that all form data is being divided into chunks, and they are sent using those chunk data. So just take example, if you have implemented in Einstein OCR, and we are uploading images, we are uploading image as a multi-part form, not a normal image form. Okay, so they actually, the system automatically, they are dividing those form data in multiple chunks and then sending those requests to the servers.
Okay, so you're saying while uploading, we are uploading as normal files, but while sending, the Salesforce internally divides with that option for the
Not
back.
we while you're designing, you should consider by default
Okay.
these applications in like Einstein OCR I have given example of Google Cloud applications or APIs, Amazon service. They already have those wherever the need of that kind of a concept. Whenever you go like image processing is required, when you are sending documents, they already if you have integrated, they need the request in multi-part form data. They have need of that kind of request format. So wherever that kind of format required, you always consider that they have divided those data in chunks.
Okay, thank you.
Because normal scenario, we always sending as application format is JSON or XML or a normal text format. But in those scenario, we are sending as a multi-part form data.